Okay, guess who's back again. Right, so the little Miev, the 14-year-old Miev that we fixed a couple of weeks ago, has got another fault. I've been driving it round. I mean, it's occasionally not starting, and I've been having to clear a fault with the diagnostic machine. And basically, it's what's called a precharge fault. It's the classic P1A15, which these cars get. We've seen quite a few of them, done a lot of work on it. Yeah, it's quite interesting. Although this is quite an obscure car, lots of the fundamental EV architecture is the same as you get in any other EV, basically, or nearly all other EVs. So it's still kind of interesting and really relevant to sort of brand new EVs today, basically. So what is happening with this car? So it's an issue when the car switches on. So under the boot, and obviously in other vehicles, these things are in different places. So this is the onboard charger DC-DC converter, and this is the motor controller or inverter, okay? Happens to be in the back in this car, but all cars will have a motor controller because they have three-phase motors. You've obviously got a DC battery, but you've got a three-phase AC motor, and you've got to change the DC from your battery into AC for your motor. So within that motor controller, there are capacitors. Now, if you've ever played with a remote control car or any kind of RC vehicle, when you connect the battery, there's a little pop, a little spark, okay? And the reason for that is that there's capacitors inside the motor controller on your RC car or whatever, plane, and there's this little inrush of current, a really small amount of power, but it just all comes at once because the capacitor can soak that power up really quickly and it wants to charge, and that's what they do. And the same happens with cars, okay? So they have capacitors inside these motor controller. They're a bit bigger than you'd find, you know, kind of in your RC car, but pretty more like that, or it could be a bank of smaller ones, but something of that magnitude. So the same thing would happen with a car in that when you turn the battery on, so the battery's got big relays inside called contactors, but fundamentally they're just big fat relays, we just call them contactors. When the battery turns on, because it's obviously not connected all the time because it's 350 to 400 volts, or in newer cars up to 800 volts, that's obviously not connected all the time, so it's switched off by relays in the battery pack, relays called contactors. So the battery's off, so we've got to turn the battery on, and we've got to close those contactors, close those relays to connect them. Now, if we just had two relays, one on positive, one on negative, and turn them both on, we'd get a spark every time. The spark would be big because the capacitor is big, and that would mean that those contactors, the relays, would last about 5 minutes because they would get pitted and they would weld themselves closed. So that's no good. So cars have what's called pre-charge, okay? So they have a little like warm-up sequence to bring the high voltage battery on. And what happens is, as well as having a positive and a negative contactor, and we're not talking about charging contactors here, okay, charging relays, we're just talking about the ones you need to connect the battery and turn it on, okay? The main relays. So you've got a positive and negative, and then you've got an additional positive. And what that is, it's connected to the same places, so it's connected to the output wire of the battery, and it's connected to the battery cells, but it goes through a resistor, a pre-charge resistor, and that is just a quite a high wattage, sort of 20 to 30 ohm resistor. And what that means is when the car starts, it turns on the negative contactor, negative relay, then it turns on positive pre-charge. So it's turning on positive and negative, but positive is going through a resistor, which just allows that trickle of current just to come through and charge up the capacitor. And then if the capacitor gets to close enough to the battery voltage, then it will turn on the main positive contactor, so the one without the relay, without the resistor, and turn off the pre-charge one, so that you've then just got positive and negative directly connected. And then you avoid that spark, and the car monitors the rise in voltage of the capacitor inside there. And as long as it gets to the battery pack voltage within a set period of time, then this sort of start continues. You know, the positive, main positive will come on, pre-charge positive will go off, and then the car's running. And what this car is saying is that it thinks that the rising voltage of that capacitor is not high enough. It's not close enough to battery pack voltage. So when it closes, if it was to close the positive contactor, main positive contactor, there would be a spark. That's what it thinks. So there's a few things that can cause this, generally speaking. One could be like a drain on a high voltage system. So let's say your air conditioning compressor's got, you know, moisture in it, and there's a link between the positive and negative. When the little trickle of current goes through the precharge resistor, that's going to get drained away, isn't it? It's going to get, you know, that moisture is going to be a load effectively in the AC compressor, and precharge is not going to get high enough. So that's the kind of things that can happen. I've seen it before on this car lots of times. And what it actually is so we said the car needs to monitor the voltage rise of that capacitor. Now on these cars, there's an issue with the measurement circuit, and they become inaccurate over time. So inside here, it's measuring the high voltage system. It's measuring the voltage of that capacitor, which is directly connected to the high voltage system. So on here, actually, you can see these are all a bit grubby, but there's 2 wires there and 3 there. So those 3 go to the motor. It's got a 3-phase motor. And then those 2 come from the battery. So that is effectively connected across those wires. So, whoop, don't lose that. Yeah, the car has got to measure this and report it back to the main ECU. So you've got a high voltage and you've got to measure it and report it onto the low voltage system. So you've got a link there between high voltage and low voltage. So if you think about this, the car's got to measure it, but it's got to keep those 2 things isolated, because you cannot have a link between high voltage and low voltage, okay? Obviously for safety reasons. So there's quite a complex circuit to measure that and isolate it as well, okay? And that's where the issue happens, basically, within that measurement circuit. So let's just have a quick look at the diagnostic machine. So we can see here, if we make that a bit bigger, I can do that. There we go. So we can see here, this is the rise in the voltage of the capacitor in the motor controller. So we can see it's going up, but if we look at it's getting to 342 and the battery voltage is 352. So it's getting there, but it's not quite close enough. And that's classic for these cars in terms of it being a measurement fault. Yeah, so what we're going to do about it, basically, so this is quite useful because where's my chip? Oh, there it is. I have got a chip and a circuit board, which is this one, which replaces the measurement board within this controller. These chips used to be blue, and you can't get the blue ones anymore, basically. So, and I do this repair every now and again, probably every couple of months or so on. And I haven't actually tried out this black version of the chip. Apparently it is a drop-in replacement, that's what I've been told. It's actually slightly cheaper, which kind of helps. Yeah, I've never actually tried it, and I don't want to try obviously on a customer vehicle first and then a garage get it back and it doesn't work. So actually this is kind of perfect timing, because I can fit that chip and we can check that works, and then we should see a more accurate voltage reading from the capacitor recorded by the car. So we've done diagnostics and we've actually measured the voltage directly on the high voltage system, and we've been able to see that there's a difference between what the car measures and what's actually there and all that kind of stuff. So we've done all that diagnostics in the past. Yeah, so basically I need to open this box up. The circuit board is at the bottom. I need to fit that. It's really fiddly soldering, but it's all doable. I should shout out Greg Fordyce, who developed this this circuit board specifically for, well, the early version of this chip, but it's still the same sort of physical dimensions. He's from a company called Go EV, I think it's called, sort of Scotland way. Yeah, and he developed this circuit board to fix this fault. I kind of get the feeling he's a bit like me, and he spends far too much time fixing obscure faults on uncommon cars. But yeah, much appreciated, Greg. And we fitted quite a few of these and fixed loads of cars, so it's really, really good. So yeah, so fiddly soldering next. So I hope that was interesting, a little bit of theory there. Yeah, we'll get this car fixed again. Cheers.